Hello everyone. In this lecture we are going to look at subroutine execution in the fetch, decode, execute cycle. So subroutines, as you are aware, is a set of instructions which are considered as a single unit. So if we take this example here, as you can see, this is your main memory. This is main memory, and here you have some code loaded. So from instruction number address 1000 onwards, you have the code or the instructions for a particular function. Let's say function main. Okay, and then in address 1002 there is a function call. So you can see here call F2. So you can see here call F2. So now what we can do is, what happens now in this case, let's see how does the fetch, decode, execute work. So as we have discussed earlier, the fetch, decode and execute, okay, after fetching the current instruction, the program counter is always incremented to the next instruction. So it starts from 1000, first instruction executed, then it goes to 1001, second instruction executed, then it goes to 1002. Now there is a change. So if you see, 1002 holds a function call. So that means before it can start executing instruction which is there in 1003, it has to jump to this location where the function f, the instructions of function f is present. So if you see this diagram, so at address 2000, from address 2000 onwards, the code for f function starts. So code for function f starts from here and goes up to here. So what it has to do, instead of incrementing the value of the program counter by 1, it has to jump to address 2000. So this point, the point to be noted here is that it is not that always the value of the program counter is incremented by 1. It can also change. So this can change because of function calls or subroutine calls. It can also change because of execution of some instructions which alter the sequence of execution of the instructions. So coming back to a function, so after at address 1002, it's a when we try to execute this instruction call f, function f, okay, the value of the program counter now is loaded with the starting address of the code for function f, and then it keeps on executing the instructions thereafter. So 2000, 2001, 2002 and so on. Now finally you can see at say address 2003 there is a function, or it's not not a function, it's an instruction. It's a return instruction. So return instruction means I have to go back to the point from where I had been called. So I have to go back to 1002. So this also means that when I had jumped from 1002 to 2000, there has to be some place where I have to store the address where I can return to. So that is known as the return address. The return address. So the return address has to be saved. Okay, when you have to save this return address when you jump to a function. Jump to a function code. Okay, so now the question is, where do you save it? The best place to save the return address is in a stack. So you have a stack where you put back the address, you push the address which you have to return to the stack, and then you keep the top of the stack pointer will be pointing to the stack. Now coming back to the return statement, now here if you see the return statement has to again modify the value of the program counter. So here I had executed program counter values became 101 to 200 2, then 2003. Now instruction 2003, before it can become 2004, 2004 is something else. So now instead of incrementing to 2004, I have to put back 1003 because that is the next instruction to be executed. So what has to be done? We have to find out where we have saved our return address, and then that value should be put back into the program counter. So the program counter will take back this value. So all we have to do is we have to pop it from the top of the stack. So, and then it continues in this manner. So if you look at this sequence of instructions, you can see the first instruction to be executed was 1000, then 1001, then 2. Then because it was a function call, you made a jump to address 2000. So 2000, 2001, 2002, 2003. Now 2003 is a return. So what you do? You pop the element at the top of the stack, the return address at the top of the stack. And where do you put it? You put it into the program counter. You load it into the program counter. So now after returning back, okay, what happens? The next instruction to be executed would be 1003. So for function calls, subroutine calls, this is how the program execution works.